Earlier, bogie disassembly and assembly was a highly manual and time-consuming process carried out across multiple isolated workstations. Each bogie had to be repeatedly lifted and repositioned using overhead cranes, resulting in excessive material movement and idle time. Assembly and disassembly activities were fragmented, with no defined process flow, and critical operations depended heavily on operator skill, leading to variable cycle times. The shop floor often became congested, raising safety concerns. This resulted in longer turnaround times and higher manpower requirements. To overcome these challenges, a streamlined and integrated system was introduced. Integrated bogie disassembly and assembly line carriage and wagon workshop, New Bongaigaon, Northeast Frontier Railways, installed and commissioned by HYT Engineering Company Private Limited. Designed with multiple integrated stations for stage-wise sequential processes, carried out in a clearly defined workflow. The assembled bogie frame is placed from the line to Station 1 for bolster disassembly using a 50-ton press. At this stage, as part of the underpit operation, the fork arm and rod link nuts are removed using power tools. The bolster is removed and carefully handled. This is followed by the removal and handling of the inner and outer secondary springs. The cross-section assembly is then removed with proper handling. After completing these operations, the bogie is transferred to the manipulator. The bogie is then lifted and rotated. Following this, the side covers are removed and handled. Finally, the wheel axle assembly is removed and handled, completing the operations at this station. At this final stage, the upper control arms are aligned and pressed. The control arm bolts and pins are then removed and handled with the help of the control arm pressing fixture. This is followed by the removal and handling of the inner and outer primary springs. Subsequently, the brake caliper units are removed by loosening. Finally, the anti-roll bar and the traction assembly are removed and handled carefully, completing the process. After disassembly, the bogie frame and bolster are sent for shot blasting and painting. Once completed, they are returned to the assembly line. The inverted bogie frame is accurately positioned on a motorized transfer trolley with the support of a gantry system. The traction assembly is then fitted to the bogie frame as per specified procedures. The anti-roll bar assembly is carefully aligned and positioned onto the bogie frame. It is then securely fastened, ensuring optimal lateral stability during operation. Brake caliper units are subsequently installed on the brake support brackets. The inner and outer primary springs are carefully placed at their designated positions on the bogie assembly. This is followed by the accurate placement and pressing of the upper control arms, which are aligned and secured. Subsequently, the half-shaft pressing fixture is fitted in position to support controlled and accurate pressing. To avoid critical safety failures, an IoT-based system is implemented to record tightening torque data of critical fasteners. Torque values are captured using transducerized torque tools and registered in the system by scanning the QR code fixed on the component. The torque tools are also designed to automatically apply the exact torque by scanning the bolt size. The wheel axle assembly is carefully handled and positioned on the inverted bogie frame, ensuring proper alignment. The axle earthing device is fitted, along with the axle end cover and the hex head plug with a copper washer. The bogie frame is then inverted and smoothly lowered onto the wheels using a manipulator. After this operation, the trolley is removed from the manipulator. The cross-section is carefully handled and fitted in position on the bogie assembly, ensuring correct alignment and secure mounting as per specified requirements. This is followed by the fitment of the lateral bump stop. The inner and outer springs of the secondary suspension are then handled and installed. Subsequently, the subcomponents are assembled on the bolster. The bolster is then inverted and placed onto the secondary suspension to complete this stage of the assembly process. The bolster pressing is first carried out using a 50-ton press. The anti-roll bar is engaged with the fork arm. The fork arm is then tightened with the rod link and centering disc to ensure proper alignment. Subsequently, the lateral damper is fitted in position, after which a load testing operation is carried out to verify structural integrity, and the press is finally disengaged to complete the process. With all components assembled and verified, the bogie is now released for the next stage of rail vehicle integration.